About wheel. Wheel can be defined as a disc or spoke with hub, which is revolving around itself at center and has a rim around the outside of this for mounting the tire. So the necessity of wheel is wheel must sustain vehicle and passenger load. It provides cushioning effect and cope with steering control. Requirement of wheel is it should be light in weight, it should be possible to remove or mount the wheel easily, it must be balanced both which is statically and dynamically. Wheel material should not be deteriorated, it must have better corrosion resistance, it should have good load carrying capacity, which is it must resist bending, tensile, compressive and torsional stresses. Cushioning effect is necessary to absorb shock load, which due to road irregularity and damp the vibration faster. So we got type of wheel. First we got press steel disc wheel, wire wheel, light alloy cast and forged wheel. Tire. Tire is a cushion provided with an automobile wheel. It consists of outer cover. As example, tire proper, which has tube inside. The tire tube is mounted on wheel rim. Necessity of tire is to reduce road shock and provide cushioning effect. Tire is responsible to improve traction, which is better friction between tire and road surface. So this is the requirement of tire. Requirement of tire should be follow this item, which load carrying capacity. Then tire should be able to carry weight of vehicle and passenger without distortion. Tire must resist bending, tensile, compressive and torsional stresses. Cushioning. Tire should absorb shock load caused due to road irregularities and damp the vibration faster. Next requirement is uniform wear, which is uniform wear reduce tire skidding and vibration due to road irregularities. So we got two types of tire. First tire is conventional tube tire, then tubeless tire. Tire operation. First, the function of tire is only contact with ground. Then it acts as the primary suspension, cushioning the vehicle from effect of rough surface. Provide frictional contact with the road surface, which allow the driving wheels to move the vehicle. Front tire allows the wheel to steer. Tire allow braking to slow or stop the vehicle. So from the figure, you can see the layer of the tire. The outer layer of the tire, we got a tread, then we got a sidewall, cap plus, body plus, inner lines, steel pads, edge cover, and bed bundle. For the layer, we can see the bed layer is a functional loop of high strength steel cable coated with rubber. It gives the tire the strength it needs to stay seated on the wheel rim and to handle the forces applied by tire mounting machine when the tires are installed on rims. The body is made up of several layers of different fabrics, which we call it as pliers. The most common ply fabric is polyester cord. The cords in a radial tire run perpendicular to the tread. Some of the tires use diagonal bias tires, tires in which the fabric runs at an angle to the tread. The pliers are coated with rubber to help them bond with other components and to seal in the air. A tire strength is often described by number of pliers it has. Most car tires have two body plies, which large commercial gentleliner often have tires with 30 or more pliers. In steel belted radial tires, beds made from steel are used to reinforce the area under the tread. This bed provides puncture resistance and help the tire stay flat so that it makes the best contact with the road. Some tires have a cap pliers, which is extra layer or two of polyester fabric to help hold everything in place. So the function of the sidewall of the layer is provide lateral stability for the tire, protect the body pliers, and help keep the air from escaping. It may contain additional components to help increase the lateral stability. The next layer is the tread. Tread is made from a mixture of many different kinds of natural and synthetic rubber. This layer is extruded and cut to length. This thread just moves rubber at this point. It does not have the thread pattern that gives the tire traction. So, the next subtopic is type of tire design. First design is all-season. The all-season touring tire is designed to deliver good comfort and handling on the highway, as well as reliable all-season transaction. It will generally feature a symmetrical thread pattern and circumference groove for wet weather grip. So, for the all-season type of design is suitable for 4 seasons, which is we got wet and weather. Next type of tire is touring. Touring tires, also called grand touring tires, are designed to deliver a comfortable ride and reliable all-season traction, with the addition of more responsive handling. They generally have a higher speed rating than all-season touring tires and often feature as asymmetrical tread pattern. So the next type of tire we got a performance. Performance tires generally have larger circumferential and lateral groove for wet weather traction. They also typically feather fairly dense piping and silica enriched tread compound for better grip regardless of the weather. They have higher speed rating than touring tires. Next type of the tire is summer. Summer tires have gear for performance in wet and dry conditions. They are not designed for all-season traction. They are optimized for warm weather and deliver grip and responsive handling in wet or dry conditions. Summer tires generally feature solid contact patches, adequate circumferential groove for hydroplaning resistance, and little to no seeping. They are ideal for performance vehicles in warmer climates. Next type of tire is track and competition. Track and competition tires are similar to street performance tires in that they are designed to deliver the pinnacle of performance. Track and competition tires are rarely used for daily driving. They are engineered to provide constant road contact in dry conditions. So the next type is highway. Highway tires have all-season tread pattern and are designed to handle the heavier load of a truck and or SUV. They are manufactured to a very comfortable on pavement. Most highway tires are durable compound and tread pattern that resist uneven wear to deliver long-lasting tread life. They generally feature seeping for enhanced all-season traction. Next up is all-terrain tire. All-terrain tires generally have more aggressive tread pattern than highway or trail tires. They have larger tread block and more voids, which provide traction in off-road driving conditions. All-terrain tires often feature the several weather service symbol. Next, we got next subtopic is about wheel alignment. Pre-alignment check. First, you check the center length of a bushing for play. Then check the pinion arm for any movement. Check the runout of the wheel and the tires. Check the vehicle right. Check the steering gear looseness at the frame. So, from the figure, we can show the typical tire check as formed in a service manual. Abnormal tire will usually indicate as a fault in steering or suspension component that should be corrected or replaced before an alignment is performed. So, technician, when we do an alignment, it should concern three items or three mainly things that we should concern, which is chamber. This item should be in inward or outward angle of the tire when viewed from the front of the vehicle. Too much inward or outward tilt is also known as negative and positive chamber. Next is toe. Toe alignment is the extent to which your tire turns inward or outward when viewed from above. If that's confusing, just stand up and look at your feet. Angle them inward toward the center of your body. Why tire alignment matters? To improve the wheel and tire alignment can cause your tire weigh unevenly and prematurely. Failure. Tires are failure when the tread is more one-sided and sharp on other. Chamber wear. Chamber wear is too significant more worn than the center of the tread. Heel or the toe wear is happen on side of your tread block, wear down more quickly than other of sequential direction. Next is static and rolling. Rolling resistance, sometimes called rolling friction or rolling drag, is the force resisting the motion when a body rolls on a surface. It is mainly caused by a non-elastic effect. So, not all the energy need a deformation of the wheel. Road bed is recovered when the pressure is removed. Two forms of this area hysteresis losses and permanent deformation of the object or the surface. Another cause of rolling resistance lies is the slippage between the wheel and the surface, which dissipates energy. Not the only last this effect involves friction. Therefore, the name rolling friction is to an extent misnomer. So the figure is shown about the hard wheel rolling on the deforming a soft surface. We can see the force from the surface having a component that opposes the position. W is standing as a vertical load on the axle, which is F, is sum towing force applied to the axle stand on the R, which is a wheel radius, and both friction with the ground and friction at the axle are assumed to be negligible and so not shown. That's all for the topic chapter 2.
Wheels are one of the first things any petrolhead will change after getting a car, but there are many different materials, constructions and assemblies, so which one is best? Steel wheels were a standard in the bygone era of cars, as they were simple to press out of billet steel, creating a strong and usable wheel for a cheap price. The drawback was that weight increased due to steel's hardy makeup. Alloy wheels were once the highest level of wheel. Based on a mix of aluminium and nickel, or magnesium and nickel, alloy wheels were much lighter yet just as strong as the equivalent steel wheel. Nowadays the cost has dropped, allowing even your base model hatchback to come standard with alloy wheels. Carbon wheels took this one step further by dropping weight even more but keeping an incredible amount of strength. A giant spindle spins strands of carbon until it weaves together, making an unbelievably strong and light material. The biggest drawback to this is the cost. A set of full carbon wheels can run you into the tens of thousands mark. Wheels have multiple different types of construction, but the main types are forged and cast. When a wheel is cast, molten metal is poured into a mould, and as it cools it becomes hard and strong. There are two main ways that this casting process is done. Gravity casting simply relies on pouring the molten metal into the mould with gravity alone, while low pressure casting pumps the molten metal into the mould at a faster speed and under pressure, helping to prevent any bubbles forming in the cast that would weaken the wheel. Forging is generally considered the best method for creating a wheel. Put simply, forging reduces the size of the grains inside the metal, making them more fine and stronger, not allowing any strength to be lost while the metal is bent around into shape. Instead of a mould being used, a single piece of aluminium billet is heated and shaped into place with over 13,000 pounds of force. Then, a CNC mill cuts the design into the block, giving the incredibly strong end result a good-looking face. You may have heard of one-piece, two-piece and three-piece wheels, but what do they mean? A one-piece is simple in construction. It has no parts other than its main wheel and face construction. A two-piece wheel naturally has two pieces to it, a face and a barrel. The face is held onto the barrel with bolts that go all the way around. The creation of split rims was so that race teams could easily change widths of wheels without having to get a brand new mould. A three-piece wheel has an extra piece, and that comes in the form of a removable front lip. In fact, the barrel is split into two pieces, further allowing you to change the size of your barrel and change offset values to dial in perfect fitment. In the end, it's down to preference, and everyone has their favourite type of wheel design, so what's yours?